Alright, welcome everybody to this short video on complex numbers where hopefully I can give you a more visual way of looking at complex numbers and give you a more visual intuition on what complex numbers are and what these operations mean. Alright, we're going to start with the number line, right word positive, left word negative. And one important thing is I want you to think of numbers purely as points. So if I say 2, I want you to think of this point 2, not say 2 apples. Because this kind of a way of looking at numbers, it gets kind of confusing after a while. For example, if I say square root of 40, the square root of 40 apples, it's kind of difficult to visualize, and it just becomes nonsense when we talk about numbers like square root of 1, because square root of 1 apples, it just doesn't make sense. So, and as you'll find out later, looking at numbers as points is much more intuitive than this idea. Alright, so we're going to start with addition. Now, there's a couple of different ways of looking at this. For example, if I have, say, 2 plus 3. There's different ways of looking at this, but the way I like to do it really is I like to look at 2. I like to locate 2 in my number line, and I like to look at this bulk as some sort of a way to modify this line, or some sort of a way to transform this line, right? And addition just says slide the plane to the right, and plus 3 means slide the plane to the right by 3 units. So if I have this plane right here, I have this. And I look at 2, let me mark 2 here, and sliding the plane rightward by 3 units just means this. Bam. So, and now you look at 2, where has 2 landed? 2 has landed on 5. That's why 2 plus 3 equals 5, and that is what addition is. And now subtraction, it's just the opposite of addition. 2 minus 1 just means look at 2, slide the plane to the left by 1 unit, and then you get 2 minus 1 equals 1. So that is subtraction. And then now multiplication. Multiplication really just means stretching the line. Keeping 0 in place, you sort of stretch this line by some factor. So if I have, again, 2 times 3, again, I look at 2, and times 3 means stretch the line by a factor of 3. This is called the scale factor, and times 3 means stretch the line by a factor of 3. Now, what do I mean by that? How do I know if I've stretched the line by a factor of 3, right? So what you do is you look at 1 and you stretch this line until 1 has now reached to 3. And I have had this pre-made, this. So if I overlay this here, 1, as you can notice, I've stretched it so that 1 is now at 3. And again, you look at 2. 2 is our initial number. Look at 2. 2 has landed on 6. That's why 2 times 3, it equals 6. And a division, it's just the opposite of multiplication, obviously. And another way of looking at this, and the way I prefer, really, is writing it this way. So instead of stretching the line, you sort of squeeze the line so that 1 now reaches to 1/3 and 2 to 2/3, and so on and so forth. So instead of stretching the line like in multiplication, you squeeze the line. And that is division. And these are the and that's the brief description of what these operations mean when you look at numbers purely as points. And it's okay for all of these points on this line. We can explore every point in this line using these operations, but what if I want to go, say, here or here? What if I want to escape this line and explore something else? So somehow we need to access this new dimension here. So if you call this the x-axis, we have to somehow find y-axis. We have to discover this new axis. So how do we do it? And one way to do it is notice this. Notice what happens when you multiply a number by -1. So if you multiply 2 by -1, it gives -2. It's sort of flipping the number by 180 degrees. It's rotating the number by 180 degrees, and 1 times -1, again, is just rotating the number by 180 degrees. And to discover this y-axis, what we have to do is find a number so that when you multiply it by that number, when you multiply 1 by that number, it doesn't rotate by 180 degrees, but it rotates by 90 degrees. So, and one thing to notice about this operation is when you do this operation twice, it's equivalent to multiplying it by -1. So if we have this number here, if we multiply it twice, it's equivalent to multiplying it by -1, which gives us x squared equals -1 and x equals square root of -1. And it's denoted by the letter I, Greek iota, but it's simply I. So that is how imaginary numbers comes into play. This is called the imaginary axis. This is called the real axis, and this is called the imaginary axis. And now we have the full axis of the entire plane. There's both dimensions for us to explore, and instead of numbers just being points on this number line, now it's a point on this plane. So this would be normally treated as the Cartesian coordinate. So it's called 1, 1. So instead of numbers being just one entity, now it's denoted by these two numbers in parentheses. So 3, 4 would be this. And these are normally sort of written as 3 plus 4i, because 3 in this direction and 4i like this, but this is more common and easier to visualize. All right, so now let's look at these operations with regards to complex numbers. And for addition, it doesn't really change much. Instead of just sliding the plane to the right, now you slide the plane to the right and to the upward direction. So 1, 1 plus 3, 4. You look at 1, 1. You slide the plane to the right by 3 units and to the upward direction by 4 units, and that gives you the answer. Subtraction, it's really instead of rightward and upward, we do leftward and downward, because both of these are negative directions. And now multiplication. Multiplication is kind of interesting because here was what multiplication was you stretch the line. So it makes sense for multiplication to be stretching the plane, and it is stretching the plane. But also notice that what we did here is we also rotated the line by some angle by multiplying it by imaginary numbers. So multiplication really is just some sort of a combination of stretching and rotating. Stretching and rotating the plane. And okay, let me give you an example so that it's easier. 1, 1 times 3, 4. All right, so first of all, we're going to stretch this. And by what factor are we going to stretch it? We're going to stretch it by this length, whatever this is. And by Pythagorean theorem, we know that this is 5 units. So we're going to stretch it by a factor of 5. And when you stretch 1, 1 by a factor of 5, it kind of looks something like this. So this is 1, 1. When you stretch it, it becomes, as you can see, I've scaled this here. It comes somewhere over here. So this is our stretched, stretched number, stretched 1, 1. And then we're going to rotate it. Now rotate it by what amount? We're going to rotate it by the same angle that this number, this line really is making with the x-axis. And by trigonometry, we can find out that this angle is about 53 degrees. So we're going to rotate this stretched number by that same angle. So if we have, that's not good. All right. Anyway, so if we have this, we're going to rotate it this by 53 degrees. So it's kind of looks like like this. So it lies somewhere over here. This was supposed to be 1,7, something like 1,7. So this gives you the product. You stretch it by whatever this length is, by a scale factor of whatever this length is, and then you rotate it by whatever angle this is making. And that's multiplication. And division really is just opposite of multiplication. Instead of stretching, you squeeze it. And instead of rotating counterclockwise, which is the assumed positive direction, you rotate it clockwise, which is the negative direction. So it kind of, you shrink it by some amount and then you rotate it in the opposite direction. So it's somewhere over here, and that's division. Anyway, so hopefully this was helpful. This is a kind of a different way of looking at numbers and operations, and hopefully this will come in handy somewhere down the road. Anyway, see ya. Bye.